Effective management requires a network management system to include a comprehensive set of data gathering and control tools, and also to be integrated with the network hardware and software. The ISO series suggests several key functions of network management. These key functions are listed here on this slide in the table. We'll take a look at each of these functions throughout this chapter. Fault management ensures that systems, either as a whole or as a part, are in proper working order. When a fault occurs, it is important for organizations to respond as rapidly as possible. Particularly, organizations need to determine exactly where the fault is and to isolate the rest of the network from this failure so it continues to function without interference. Also, organizations are required to reconfigure or modify the network to minimize the impact of the operation without the failed components. In addition, they should repair or replace the failed components to restore the network to its initial state. Fault is central to the definition of fault management. A fault refers to an abnormal condition that causes a device or system component to fail to perform in its required manner. It also requires management attention for repair. It is usually indicated by failure to operate correctly or by excessive errors. When a fault arises, users generally expect to receive immediate notification. They also expect the problem to be corrected most immediately. Given that users expect to be kept informed of the network status and network operation, problem tracking and control should be performed. In other words, after correcting a fault and restoring a system to its full operational state, the fault management service must ensure that the problem is truly resolved and that no new problems are introduced. To satisfy aforementioned requirements, fault management generally includes several functions, such as maintaining and examining error logs, accepting and acting upon error detection notifications, tracing and identifying faults, carrying out sequences of diagnostic tests, and correcting faults. Many organizations often charge the use of network services to individual decisions or cost centers, or even individual project accounts. These are internal accounting procedures rather than actual cash transfers. Even if there is no such internal charging, a network manager should be able to track the use of network resources by users or user class due to the following several reasons. First of all, a user or a group of users may abuse their access privileges and burden the network at the expense of other users. Second, users can make inefficient use of the network, and the network manager can assist in changing procedures to improve performance. Finally, the network manager is in a better position to plan for network growth if user activity is known in sufficient detail. Several functions are generally required for accounting management. Accounting management should include a function that informs costs incurred or resources consumed by users. Also, it should be able to set accounting limits and tariff schedules that are associated with the use of resources. In addition, it should provide a function that allows combining costs invoked by multiple resources to achieve a given communication objective. Once it is decided how a device is used, the configuration manager chooses the appropriate software and the set of attributes and values for the device. Configuration management is concerned with initializing a network and shutting down part or all of the network. It is also concerned with maintaining, adding, and updating the relationships among components and the status of components during the network operation. Network managers usually want only authorized users to manage and control network operation. To satisfy such needs, configuration management generally includes several functions, including setting the parameters that control the routine operation of the system, associating names with managed objects, initializing and closing down managed objects, collecting information and demand about the current condition of the system, obtaining announcements of significant changes in the condition of the system, and finally changing the configuration of the system. At present, many organizations intercommunicate and share their data and resources. In some cases, it is critical for data communications to meet certain performance limits. Performance management of a computer network comprises two broad functional categories: monitoring and controlling. Monitoring refers to the function that tracks activities on the network, whereas controlling function enables performance management to make adjustments to improve the network performance. There are several performance issues that a network manager concerns, such as is there excessive traffic, are there bottlenecks, and is response time increasing? To deal with these concerns, a network manager needs to monitor a set of resources and assess performance levels. Therefore, performance management must monitor many resources to provide information on determining the level of network operation. In addition, performance management needs to include several general functions, including gathering statistical information, maintaining and examining logs of system state histories, determining system performance under natural and artificial conditions, and altering system modes of operation for the purpose of conducting performance management activities. Security management is concerned with gathering, distributing, and storing encryption keys. It is also concerned with monitoring and controlling access to computer networks and access to all or part of the network management information obtained from the network nodes. Logs are an important security tool. Therefore, security management is very much involved with the collection, storage, and examination of all the records and security logs. It is also involved with the enabling and disabling of the logging facilities. Accordingly, security management provides facilities for protection of network resources and user information. Obviously, network security facilities should be available for only authorized users. As mentioned earlier, the purpose of security management is to support the application of security policies through some functions. These functions allow security manager to create, delete, control security services and mechanisms. They also allow the distribution of security-related information and the reporting of security-related events. A large network cannot be put together and managed by human effort only. Therefore, many organizations use automated network management tools, and these tools need to be properly managed as well. A network management system is a collection of tools and network monitoring and control that is integrated into a single operator interface. The interface provides powerful commands for performing network management tasks. Specifically, a network management system consists of incremental hardware and software additions that are implemented among existing network components. Therefore, a network management system is designed to view the entire network as a unified architecture. It shows addresses and labels assigned to each point, as well as the specific attributes of each element and link known to the system. The following figure here on the slide shows the principal components of a network management system. Each network node contains a collection of software devoted to the network management task, referred to as the network management entity. Each network management entity performs several tasks, including collecting and storing statistics on communications and network-related activity, sending messages to network control center, and response to commands from the network control center. At least one host in the network is designated as the network control host or manager. In addition to the network management entity software, the network control host includes a collection of software called the network management application. The network management application includes an operator interface to allow an authorized user to manage the network. The network management application responds to user commands by displaying information or by issuing commands to the network management entities throughout the network. Every other node in the network is referred to as an agent. Agents include end systems such as workstations that support user applications, as well as nodes such as servers and routers that provide a communication service. As illustrated in this figure, the network control host communicates with and controls the network management entities in other systems. In traditional centralized network management system, one host has the role of a network management station. As networks grow in size and traffic load, the centralized system is unworkable because too much burden is placed on the management station, and there's too much traffic. In such circumstances, a decentralized, distributed network management system works best. In a decentralized network management system, there can be multiple top-level management stations, which are referred to as management servers. As shown in this figure, each management server directly manages a portion of the total pool of agents. However, for many of the agents, the management server delegates responsibility to an intermediate manager. The intermediate manager plays the role of manager to monitor and control the agents under its responsibility. It also plays an agent role to provide information and accept control from the higher-level management server. Therefore, it spreads the processing burden and reduces the total network traffic. Cisco has developed a hierarchical network management architecture. Its architecture is illustrated in this figure. Since the details of this architecture is beyond the scope of this course, we'll only provide a brief summary. The architecture consists of 3 layers. So the bottom layer is the element management layer. It provides an interface to the network devices and communication links in order to monitor and control them. The middle layer is network management layer. It provides a level of abstraction that does not depend on the details of specific elements. Finally, the top layer, service management layer, is responsible for adding intelligence and automation to filter the event correlation and communication between databases and incident management systems. The goal of the network management architecture is to move traditional network management environments and operations personnel from element management to network management, and from network management to service management. One example is moving from managing individual alerts to managing network events, and finally to managing identified problems.